6.3, multiplication of a vector by a scalar. Okay, so just as a quick review, a vector has a magnitude and direction. A scalar is just like a number. It just has a magnitude. Okay, so multiplication of a vector by a scalar. For the vector Ka, whereas this K is a scalar and is a constant, basically. Okay, we've seen this before. Okay, where K is a scalar and vector A is a non-zero vector. So this symbol on top of the A means that it's a vector. Okay, so here are the laws. Number one, if K is greater than 0, then K times vector A is in the same direction as vector A with the magnitude of K times whatever the magnitude of vector A is. Okay, it's just, essentially this is just saying it's 3 times the length. Or sorry, K times the length. For K is greater than 0, 2 different possibilities will be considered and are illustrated in the following diagram. Okay, so if K is between 0 and 1, the vector is shortened, but in the same direction. Okay, so an example of this is like vector 1/2 A is half the length of A and in the same direction. Okay, so for example, if this here is A, then like half of A would kind of be cut off here, and then we would essentially take this and put the arrow here, which is what we do right here. Okay, so if we're multiplying basically by, and I don't want to say fraction because a fraction can be greater than 1, but 0 decimal something, then it's going to be, the vector is going to be shortened. And if K is greater than 1, then the vector is lengthened. Okay, again, the direction stays the same. Okay, because we're not dealing with that negative yet. We're not flipping it. Okay, so whatever K is, it's going to be same direction, just longer. So an example of this is like 3/2 vector A. It'd be 1.5 times longer than vector A, and then in the same direction. Okay, and then the second situation is if K is less than 0. So all that means is that if K is negative, what it's going to do is it's going to be in the opposite direction of A, and then with a magnitude of K times A. And see these absolute value brackets? That just means deal with the number. So the magnitude is just going to be the magnitude of K times the magnitude of A. Okay, again, 2 situations arise. Okay, so if K is between -1 and 0, in other words, if it is negative and a fraction, and I'm going to put fraction in quotation marks, okay, then what happens is it's shortened and it changes to the opposite direction. So if this is vector A, say half of vector A is to here. So we would usually have, this would be 1/2 vector A, but because we're dealing with the negative, it changes direction. Okay, so example, vector -1/2 A is half the length of the original vector in the opposite direction. Okay, and now K is less than 1. Okay, so again, K is less than 1, a negative number, and that actual number itself is greater than 1. Okay, so what happens is, for example, vector -3/2 A, it's 1.5 times as long as A, but because of this negative symbol, it's in the opposite direction. So this one here is lengthened and changes to the opposite direction. Okay, and I just want to make a point, if this is the direction of A, this is the direction of -A. Okay, if this is the direction of A, then this is the direction of -A. Okay, so it's the exact same direction, you just take the arrow and put it on the other side. Example 1, an airplane is heading due north at 1,000 kilometers per hour. The airplane's velocity is represented by vector v. Okay, so this is our vector here. Remember, never eat shredded wheat. Okay, there's our compass. So what we're going to do is we're going to draw vectors, negative v, 1/2 v, and negative 1/2 v. And then we're going to give an interpretation for the data. Okay, so I'm going to actually put this one down here so we can work in the middle of the screen. Okay, so for negative v, v goes north, so negative v is going to go south. Negative vector v. Okay, and what this means is heading due south at 1,000 kilometers per hour. Okay, now what about 1/2 v? So v is north, okay, 1/2 is probably about this height here. Okay, so this is going to be 1/2 vector v. Okay, so same direction, just half of the vector. Okay, so this would be heading due north still. Okay, same direction, doesn't change because there's no negative on it. Okay, but instead of 1,000 kilometers per hour, it's going to be half of that. It's going to be 500 kilometers per hour. Okay, and then last one, negative 1/2 v. Well, we know this is 1/2 v, so let's go in the opposite direction. So from vector v, we're going to take half of it and then go in the opposite direction. So this is going to be negative 1/2 vector v. And this is heading due south at 500 kilometers per hour. So here are some special cases. When k equals 0, so if we multiply any vector a, like for example vector a, by a scalar 0, the result is always the 0 vector. Okay, so for example, 0 times vector a equals the 0 vector. Okay, because remember, then we're going to have 0 as the magnitude. Okay, and when k equals -1, okay, here's another special case. When any vector is multiplied by -1, its magnitude is unchanged, but the direction changes to the opposite. That's it. So 4 times vector a would just be now -4 times vector a. Okay, so same direction, opposite, same magnitude, opposite directions. Okay, and if we're just taking a look at this diagram, if this is vector a, okay, we can have such things as root 2 vector a, right? But if you did root 2 in your calculator, I believe it's 1.4. Okay, that's essentially like 1.4 times vector a. Or 2 vector a could be a decimal, you could have it in. It could be a negative with a decimal, it could be a fraction. Okay, so lots of different examples here. Okay, and then there's something called collinear vectors. So what does this mean? If you think about the words here, co means to share, right? So in school you have like co-heads or co-coaches, right? Like you guys are both coaches, so you share. And then if we're talking about linear, I know there's like another L in here, that's fine. Linear, you're thinking line. Okay, so what's a collinear vector? When two vectors are parallel or lie on the same straight line, there we go, that's what it is. So they are collinear since they can be translated so that they lie in the same straight line. Okay, guys, every line is straight. Okay, but I just added it in there so that we remember. Vectors that are not collinear are not parallel. When discussing vectors, the terms parallel and collinear are used interchangeably. Okay, so two vectors u and v are collinear if and only if it is possible to find a non-zero scalar k, such as u, like vector u equals k vector v. So we have example 2. The vectors, vector x and vector y, are unit vectors. Okay, so what unit vectors are they're vectors with the magnitude 1. They're 1 unit. Okay, that make an angle of 30 degrees with each other. So we're going to calculate the value of the magnitude of 2 times vector x minus vector y. Okay, so originally what we do is if they are at an angle of 30 degrees to each other, we start by drawing them tail to tail. Okay, so let's call this one x, let's call this one y. So for A, we want to calculate the magnitude of 2 times vector x minus vector y. So if we think about it, x is going in, we drew it going kind of east, right? So we're going to multiply that by 2. So we're going to have 2x about this long. Okay, and then vector y we had going up like this because these are 30 degrees to each other. So instead of drawing vector y going up, because we have negative y, so minus y, we're going to draw vector y going down. Okay, and the magnitude of that is still 1 because remember it's a unit vector. Okay, so our actual resultant is going to be from the start to the end. Right, tail to tip. So this is going to be called, we always call this the resultant vector, which we denote oftentimes by R. So if we're thinking about what angle is, if we have any of these angles, we actually have the angle between 2x and 1y. So like 2 times vector x times 1 times vector y. So what happens is in the original, they were at 30 degrees to each other. So if we pick this up and we put it here, we know that like turning on the side, we have 2 parallel lines, which are the y's right here and here. And then we have a transversal. So going back to maybe grade 9, we can use the Z pattern, where those two would be the exact same measurement. So in other words, this right here would be 30 degrees. Okay, so if we have the magnitude of 2 of these sides and then the contained angle, what we can do is we can solve for the magnitude of R using cosine law. So 2 times vector x minus vector y squared, because that's the magnitude, right? Like the R squared, is going to equal 2 times vector x squared plus 1 times vector y squared minus 2 times the magnitude of 2 times vector x times the magnitude of vector y cos 30. Okay, so let's go ahead and just write this as like vector r. Okay, the magnitude of vector r equals, so 2 times a unit vector is just going to have the magnitude of 2. So this is going to be 2 squared. 1 times the unit vector is going to just have a magnitude of 1, so plus 1 squared. And then it's going to be minus 2 times, same thing, 2 times 1 times cos 30. Oh, this has a squared on it. Okay, so 2 squared is just 4, 1 squared is just 1, so that's 5 minus, and then that's going to be 4 times cos 30 is, if you think about cos 30 versus 60, okay, this is going to be 1, 2, root 3. So cos of 30 is going to be root 3 over 2 as an exact. Okay, and then the 4 and the 2 can cancel out. 2 goes on the top. Okay, so we're going to have 5 minus 2 root 3, and that's going to equal the magnitude of vector r. So we can definitely root both sides. So what that's going to equal is 1.24. So the magnitude here is 1.24. Okay, and if you go up to the original, there's no units, so 1.24 units is just fine. Okay, now B, determine the direction of 2 times vector x minus vector y. Okay, so here's the thing. So this resultant, we're going to find this angle in here. So we can use sine law. Okay, we don't have actual like east, west, north, south. So we're just going to talk about the angle as per the vector x and the vector y. Okay, so let's go B. So we're going to have, let's just name this, we'll keep this as R. Okay, so we're going to have sine that's fine. Let's just put R, okay, over, and it's going to be 1. .24. Okay, so this is R. Okay, so sine R over R is going to equal sine theta over Y. Sine theta over Y. Okay, so we're going to have sine R, sine 30 over 1.24 is going to equal sine theta, which we don't know, over the magnitude of this side is 1. Okay, so let's draw this up here. We have, so 1 just goes away, that's fine. We can have, so sine theta equals, well, what's sine 30 over 1.24? I get 0.4, 0.3225, and so on. Okay, so that's enough decimals. So what we're going to do is we're going to sine inverse both sides, sine inverse, and we're going to have theta equals 24 degrees. So we can write a therefore statement. And our therefore statement is going to be, therefore, vector R has a magnitude of 1.24 and direction of, so how we quote this when we don't actually have like an east, west, north, south, all we know is that they were 30 degrees from each other, right, from the original. So what we would quote this as is 24 degrees rotated clockwise, which is this way, okay, rotated clockwise relative to x. Okay, vector x. So we're quoting it in terms of where it lies from like the first vector that we dealt with, which is vector x. Okay, example 3, an airplane is flying in the direction north 30 degrees east. Okay, so I want to talk about that first. So if you had, I'm going to give you an example. Okay, so we had never eat shredded wheat. Okay, if we're in a direction of north 30 degrees east, what we want to do is we want to start by going north, and then we want to rotate this way 30 degrees toward the east. Okay, so exactly how you read it, that's how you draw it. You start north, then you go 30 degrees toward the east, draw your vector. Okay, so let's continue. At an airspeed of 240 kilometers per hour. Okay, so that's that vector. The velocity vector for this airplane is represented by vector v. So this is going to be vector v. So A asks us to draw a sketch of -1/3 of vector v and state the direction of this vector. So let's just draw a new one. Okay, so 1/3 of 240, if you think about it. So, and I'm going to do this here. 240 divided by 3, I believe is 80. Okay, so 1/3 is going to be 80 kilometers an hour. But because it's negative, instead of going right here, what happens is we continue through. So our vector is going to be right here. This is going to be -1/3 vector v. This is going to be traveling at 80 kilometers per hour. Okay, and if you think about it, this angle here, let's do another color. This angle here was 30. That means because of opposite angles, this angle here is also 30. Okay, so what we can quote is 80 kilometers per hour, and then we can quote the direction. So this is south 30 degrees west. Okay, and now for B. For the vector 3/2 of vector v. So that's like 1.5 times, okay? So, again, never eat, try to eat. Okay, so 240 times 3/2, okay, which is essentially times 1.5, is 360. And that's going to be in kilometers per hour. Okay, now it's going to have the same direction. It's just going to be longer. So this is still going to be 30 here. Okay, but then this is going to be 3/2 vector v. So it's going to be 360 kilometers an hour in the direction of north 30 degrees east. Unit vector. It is sometimes useful to multiply the non-zero vector x by the scalar 1 over the magnitude of vector x. When we multiply vector x by 1 over the magnitude of vector x, we get the vector, obviously, like 1 over the magnitude of vector x times vector x. Okay, that makes sense. Those are just multiplied. This vector is of the length 1, so this is now called the unit vector, which points in the same direction of vector x. Unit vectors are useful in applications of vectors, okay? So these unit vectors, they're not going away, they're coming back. Okay, so take a look over here. If we had some unit x, and say the magnitude here is 3, right? Like 1, 2, 3. Okay, so the magnitude is 3. So if we had 1/3 of vector x, that would also equal, like if we brought out the constant, right? 1/3 of the magnitude of vector x, and it would also equal 1/3 times 3, which is 1, right? Because the magnitude of vector x is 3, which is from like the original. So it's 1. So then this gives us our unit vector. Okay, so the whole point of a unit vector is to be 1 unit long. So, example 4, given that the magnitude of vector u is 4 and the magnitude of vector v is 5, and the angle between vector u and vector v is 120. Okay, so as an example here, this is going to be vector u, and this is going to be vector v, and the angle between them is 120. What we want to do is determine the unit vector in the same direction as u plus v. Okay, so I'm going to put 4 here, and I'm going to put 5 here. Okay, so if we did u plus v, what we would be doing is we would be picking up v and putting it here. Okay, so let's do that. Let's go. Vector u, which we know is 4 units, plus vector v, which we know is 5 units. Okay, because we want to go tail to tip, tail to tip. Okay, and then this is going to be our resultant. So if we think about it, we have vector u plus vector v squared equals, okay, so let's actually think about what angle is between these. So if this is 120, and we can think parallelogram, okay, if both of these are 120, well, if you remember in grade 9, the C pattern, both of these are gonna add up to 180. So this right in here or this right in here, if we had a C pattern like this, okay, remember 2 parallel lines and the transversal going through it. So that's going to be 180 minus 120. We're going to get 60. Okay, so we're going to do the magnitude of vector u squared plus the magnitude of vector v squared minus 2 times the magnitude of vector u times the magnitude of vector v cos 60. Okay, we're using cosine law again because we have 2 magnitudes and the contained angle. So this we're actually calling the resultant now. And the magnitude of vector u is 4. So 4 squared plus magnitude of vector v is 5 squared minus 2, 4, 5, cos 60. Okay, here we have 4 squared is 16, 5 squared is 25. So we have 41 minus 2 times 4 times 5 is going to be 40. But then this is multiplied by cos 60. So special triangles, if we have 30, 60, 90, 1, 2, we're going to have root 3. Okay, so the cos of 60 is 1/2. Okay, 1/2 of 40 is 20, so we get 21. Okay, so root both sides, we get the magnitude of vector r is going to be root 21, or in other words, 4.58. Okay, that's going to be the magnitude right here, 4.58. So our question, back to the question, determine the unit vector in the same direction as u plus v. So to create a unit vector in the same direction, multiply by one over the magnitude of unit v plus, or unit u plus vector u plus vector v. So what that is in this case, it's going to be 1 over root 21. And you know what? I would leave it as root 21. It's going to be exact. So in other words, we're going to have vector u plus vector v is going to be vector u over root 21 plus vector v over root 21.